Let's unpack this. When you picture Benjamin Franklin and his kite, you probably imagine, this really dramatic scene.
Right, lightning everywhere, maybe.
Exactly. A lone figure defying a massive storm. It's such an iconic image, isn't it?
It really is.
But the actual story, well, it's far more subtle and, honestly, scientifically, much more rigorous. Maybe even more impressive than the myth.
Absolutely. It's a great opportunity to sort of separate that familiar folklore from what actually happened. Because Franklin wasn't just, pulling a stunt. He was systematically trying to unify two things that seemed worlds apart.
Which were?
The huge, frankly terrifying power of a thunderstorm and those tiny little sparks you get from static electricity in a lab.
Okay.
So our mission today really is to get behind that image and see the actual genius at work, understand its real impact.
Right. And this is where it gets really interesting, maybe a bit surprising for some folks.
Go on.
That massive lightning bolt striking the kite, the one we all picture. It never happened. I mean, think about it. If a direct bolt had hit the kite,
he wouldn't be around afterward. Instant fatality.
Exactly. So that's the first big myth busted.
So, okay, if it wasn't a direct strike, then what actually was going on? How did he tap into the storm's electricity?
Well, the setup was quite clever and relatively safe, actually. He and his son William used a silk kite. Silk holds up better in the wet, apparently.
Makes sense.
And it had a pointed wire at the top. Then a hemp string ran down from the kite.
Hemp, right. Which gets conductive when wet.
Precisely. And down near his hand, there was a key tied to the string. But, and this is crucial for safety, he held onto a dry silk ribbon tied to the hemp string.
Ah, the insulator.
Yes. And he stood under cover, like a shed, to keep that ribbon dry. As the rain soaked the hemp string.
It became a conductor, pulling charge from the cloud.
Exactly. Drawing down the ambient electrical charge from the thundercloud passing overhead. Not a bolt, just the static in the air.
So the big aha moment wasn't some giant flash.
Nope, it was actually, pretty subtle. First, he noticed the loose threads on the hemp string standing on end, repelling each other.
Ah, classic sign of electrification, like rubbing a balloon on your hair.
Right. And then, when he brought his knuckle close to the key,
a little spark jumped across.
A tiny spark. That was it.
Yeah.
That was the conclusive proof he needed.
Proof that the electric fire from the storm, as he called it, was exactly the same stuff, the same properties as the static electricity he'd been playing with in his lab.
Same phenomenon.
And let's be clear, this wasn't about discovering electricity, right? People had known about static effects for, centuries. Thales of Miletus, William Gilbert.
Right. Ancient Greeks and all that.
Franklin's real genius here was proving the connection. Showing that lightning wasn't some supernatural act of God, like Zeus throwing bolts or Thor's hammer.
Or something you could ward off by ringing church bells, which they actually used to do.
Exactly. Futile and dangerous. He turned it into a natural, explainable phenomenon. He basically demystified the heavens in that respect.
And that systematic approach that was so typical of the Enlightenment thinking, wasn't it?
Absolutely. This wasn't a random flight of fancy. Remember, he'd retired from printing at just 42.
Pretty young.
To dedicate himself to science. He'd done countless experiments, even shocked himself pretty badly a few times, apparently.
Ouch. And he was already challenging existing ideas, like the theory of two opposing electrical forces.
Right. He proposed his single fluid theory. Too much fluid was positive, too little was negative. It wasn't quite right, but it was a huge conceptual leap.
And speaking of concepts, he basically had to invent the words for them, too.
Oh, absolutely. This is a fascinating, often overlooked part of his legacy. The vocabulary just wasn't there.
So words like
battery, charge, condenser, which we now call a capacitor conductor, plus, minus. These are all terms Franklin coined or popularized in an electrical context.
Wow. So the plus and minus signs on the batteries we use every day.
Directly trace back to Franklin's way of thinking about electrical charge. It's incredible linguistic groundwork.
Amazing. Now, he wasn't working in a total vacuum, though. Other scientists were exploring electricity, too.
Definitely, especially in Europe. People like Dalibard in France had actually performed a similar experiment, the sentry box experiment, possibly even before Franklin's kite flight, proving lightning was electrical.
But the risks involved in all this experimentation? They were serious.
Extremely serious. And that brings up a really important, tragic point. Just a year after Franklin's experiment in 1753, a Russian physicist, Georg Wilhelm Richmann.
Yes, Richmond.
He was attempting to quantify the electricity during a storm, replicating a similar setup, but he apparently stood too close to an ungrounded conductor.
And what happened?
He was struck and killed instantly by what witnesses describe as a globe of blue and whitish fire.
Oh, wow. That really highlights the danger.
It absolutely does. And it underscores how careful Franklin was with his setup, the silk ribbon, standing under cover. Prudence was key.
So bringing it all together, what's the biggest takeaway for us today? What's the lasting legacy?
Well, the most direct practical consequence of proving lightning was electricity was, of course, his invention of a lightning rod.
Right. The device to protect buildings.
Exactly. Based on his doctrine of points, the idea that sharp points could draw off electrical charge silently, or, if a strike did happen, provide a safe path to ground.
And it worked?
It worked incredibly well, protecting homes, churches, public buildings. There's that famous story about the British Navy during the Napoleonic Wars.
Oh, yeah.
They supposedly refused to adopt lightning rods because Franklin was an American rebel. They lost something like over 200 tall ships to lightning strikes.
Wow. Well, American ships, presumably with rods, were
Largely protected, yes. A very practical, if costly, lesson in letting politics interfere with science.
And from that basic rod design, we've obviously developed much more sophisticated lightning protection systems today.
Absolutely. Protecting not just buildings, but all our incredibly sensitive modern electronics, too. It all stems from that initial understanding.
So Franklin's real greatness here seems to be that combination of, well, tireless curiosity, a really careful method.
Meticulous method, yeah.
Wow.
And the ability not just to understand something profound, but to name it, give it language, and then immediately turn that knowledge into something practical that benefits everyone.
Harnessing the electric fire, as he put it.
Bringing it down to earth, quite literally, and making it safer for society.
So the next time you see lightning flash, or heck, even just pick up a AA battery, remember the real story of Ben Franklin and his kite? It's less about daring and more about brilliant, careful science.
He wasn't just an inventor playing with sparks. He was a unifier of scientific ideas, a creator of scientific language, and a deeply practical engineer.
A true, multifaceted genius.
Definitely. And, leaves you with a thought, doesn't it?
What's that?
How many other everyday things, maybe even phrases we use, still carry that intellectual DNA from Enlightenment thinkers like Franklin, shaping our world in ways we just don't even think about anymore?